Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss conclusions from Kroning-Penny model as an idea of band gap, Brillouin zones and effective mass of an electron. Let's begin. In the previous video lecture, we have already discussed about what is Kroning-Penny model and we derive that particular equation as P sin alpha A divided by alpha A plus cos alpha A is equal to cos Ka, where P is referred as the scattering power. If we plot a graph between that term P sin alpha A divided by alpha A plus cos alpha A to that of alpha A along x axis and that quantity along y axis, that graph is looking like this. But the value of cos Ka within that -1 to +1 as cos Ka, that range from -1 to +1, that is cos Ka is equal to that quantity. Instead of cos Ka, we can write that quantity. So, -1 less than equal to P sin alpha A divided by alpha A plus cos alpha A, that is less than equal to 1, that value within that of range -1 and +1. So, +1 and -1, that is the value of cos Ka, that is the value of Ka. Therefore, above that +1 and below that -1, the regions at which in these regions that equation does not satisfy. Therefore, the regions where that equation is satisfied except that shaded regions, the regions except that shaded region is in between these shaded regions, it is not allowed, that is known as the forbidden region, except that line to this line, that region is allowed regions. That line to this line is allowed, since in between these shaded regions, that region is forbidden. Next, in between these two lines, that is allowed, within that not allowed, that is forbidden. Next, this line to this line, that is allowed. We write here the energy spectrum an important point. The energy spectrum of electron within that of periodic lattice, in the periodic lattice, that periodic lattice consists of allowed as well as forbidden bands. Allowed and forbidden bands. As we confirm from that particular graph, the allowed bands are shown in thick dark lines separated by intervals. Where the allowed bands are shown in thick dark lines separated by intervals where there are no energy levels. No energy levels, and the boundaries of the allowed bands corresponds to the values of cos Ka. That value is equal to plus minus 1 or Ka, its general solution as n pi. Therefore, K is equal to n pi by A. Thus, the wave number should be an integral multiple of pi by A. Here the energy spectrum of the electron in that periodic lattice consists of allowed as well as forbidden bands, and the allowed bands are shown in the thick dark lines separated by intervals. See the allowed bands, allowed bands, allowed bands, allowed bands, and that range as here is minus pi, pi, 2 pi, 3 pi, and so on. The allowed bands correspond to that of value as cos of K is equal to plus minus 1, that is cos n pi. Ka is equal to n pi, therefore K is equal to n pi by A. So, wave number should be an integral multiple of pi by A. N is equal to 1, 2, 3, like we obtain that value. Next, Brillouin zones. If we plot the graph in between the NRC and the wave number k, so that graph discontinues at some values of k, and that values are pi a, 2 pi by a and 3 pi by a. If we plot the graph between E versus k, then it is discontinue at k is equal to pi by a, 2 pi by a, 3 pi by a up to n pi by a, where n is an integer, that is value of n is equal to 1, 2, 3 like this. For k is equal to 1, the k values gives us first, second, third, like that of Brillouin zones. K is equal to 1 for first Brillouin zone. For k, that value, that is pi by a to minus pi by a, pi by a to minus pi by a, that is extends, is known as first Brillouin zone. First Brillouin zone. First Brillouin zone. Next, pi by a to 2 pi by a, it is second Brillouin zone. For k, pi by a to 2 pi by a, that is second Brillouin zone. Next, for third Brillouin zone, that range is 2 pi a to 3 pi a, that is third Brillouin zone. For k is equal to 2 pi a to 3 pi a, that one is third Brillouin zone. By using Kroning-Penny model, we show various Brillouin zones by plotting the graph in between NRC and wave number. That region is the forbidden band, where NRC are not allowed. Next, effective mass of an electron. From de Broglie hypothesis, wave packet which is associated with moving electron and the group velocity denoted by V of G of the wave packet is same as that velocity of electron. That is, velocity of electron is equal to that velocity of group velocity, which is differentiation of d omega of decay. As we know, our velocity v is equal to, in place of omega, the energy associated with electron, energy associated with electron E is equal to h cut omega. In place of omega, we can substitute E by h cut, therefore d by decay of E by h cut, or V is equal to 1 by h cut dE by decay, at the velocity of electron. Then the acceleration of that of electron, the acceleration of the electron, that electron moving in an external electric field, that external electric field is given by zeta, as the E referred as the energy term. Therefore, another notation, zeta is used for external electric field, that is given by A acceleration, rate of change of velocity dV by dt, or A is equal to d by dt of velocity term 1 by h cut d by dk, or A is equal to 1 by h cut d square E d k square dk of dt, just differentiating it with respect to dt. Now, if Q is the charge on electron, then the small work done and that work done is equal to that energy, that small work done, that is small energy dE in moving the electron by displacing distance dx by the external force charge into that external electric field zeta is the small work done dE, force into displacement. So, force q zeta displacement dx is equal to q zeta, dx can be written as dx by dt into dt is equal to q zeta dx by dt, that is the group velocity v of g dt is equal to q zeta, instead of group velocity 1 by h cut dE by dk, 1 by h cut dE by dk into dt, dE cancel out on both sides, therefore we obtain dk by dE is equal to q zeta divided by h cut. Hence, the acceleration term, acceleration A is equal to q zeta by h cut square d square E by dk square, or q into zeta is equal to, that is h cut square divided by d square E by dk square into A, that one is equal to force, a quantity, into acceleration, force is equal to mass into acceleration. So, that term, therefore, the effective mass of vibrating electron in the crystal is effective mass m effective of that vibrating electron, which is equal to h cut square divided by d square E by dk square. Whereas q zeta divided by A is nothing but mass, force by acceleration, which is the expression for mass, and the effective mass of electron in a crystal is inversely proportional to that of d square E by dk square. The expression for effective mass of electron, first we calculate its velocity, then acceleration. By using that acceleration concept, force is equal to mass into acceleration, the effective mass of vibrating electron in that of crystal is evaluated. So, with the help of this video lecture, we understand the concept of conclusions from Kroning-Penny model as an idea of band gap. By taking the graph, we confirm what is allowed bands and forbidden bands in case of Kroning-Penny model, and then Brillouin zones, plotting the graph in between energy and wave number. Various Brillouin zones are calculated. Next, effective mass of electron from de Broglie hypothesis, the velocity is equal to that group velocity, then acceleration expression. Using that equation, force is equal to mass into acceleration, we confirm what be the effective mass of vibrating electron in that of crystal. So, with this useful and informative notes, let me wind up this session. Thank you.